Hi, this is a classical equilibrium problem, and it always helps in these kind of problems to have a good diagram. So I put this in ahead, and I think you can confirm the conditions of the problem are shown here. So we have these two support threads, um, which have to balance the downward force of gravity on the bar. But we don't know until we look at the rotational equilibrium how that's distributed. By looking at the sum of the torques, uh, we see that this can only equal zero if T2 is twice as large as T1. Okay. And since we know that the sum of them is 5.88, that means that T1 is going to have to equal 1.96 newtons, and T2 must be twice that. And that adds up to the 5.88 that is the force downward. In the second part of the problem, we add this weight at a point such that we now make the two tensions equal to each other. This time, it's easier to solve the linear problem first because we have the condition that the two must be equal. They have to balance the weight of both the bar itself and the 400-gram weight that's hanging from it, totaling exactly 1 kilogram. All right, so we see then that each one must have a tension of 4.9 newtons. And now we can use those two tensions to calculate the new torques for T1 and T2. And we know then that the torque for T3 must help add all those to zero. So that's shown in this equation here, where x is the unknown distance we have to hang it from. Okay, so simplifying, we get this equation right here, and final result is 0.0625 meters to the left of center. And by the way, center is the obvious place to choose for your rotational equilibrium because it's in the center, and that means that the two torques caused by the weight of the bar itself cancel out. Hope this has been helpful for you.